Hello friends, welcome to Knowledge India once again. In this particular tutorial, we are going to talk about network load balancer. We will see with a comprehensive demo that how to set up network load balancer. We'll go ahead and look at different attributes. We'll see that how to set up target groups, how to set up rules and all of that. We will also go ahead and talk about some of the differences and the new features which we have got along with network load balancer and why is it better than some of the older load balancers which AWS used to give. Okay, so what I've thought is that I will do the demo part first and then I can go ahead and talk about some of the features. That way you would be able to relate it more. I don't want to do the feature thing first. Okay, so first let us go ahead and do the demo part. So before we move forward, uh, network load balancer is the third load balancer which Amazon introduced. Before this, there used to be classic load balancer and application load balancer. So uh, now the classic load balancer is kind of becoming obsolete. They might remove it after some time, but application load balancer and network load balancer are going to be there. So network load balancer is layer 4 load balancer, whereas the application load balancer is layer 7. In case you are interested to learn about classic load balancer and application load balancer, there are detailed tutorials around them as well on our channel, youtube.com/knowledgeindia. So you can go ahead and look at those tutorials and learn the same. Now let us go ahead and get started with the network load balancer. So as you can see, in order to show you this demo, I have done few preparation before itself. Uh, we have our VPC in which I've got 4 subnets as you can see on the screen. There are 2 public subnets, 2 private subnets, and they are spread across 2 different availability zones. Okay, I have also gone ahead and launched 2 EC2 instances as you can see. One out of that is Linux and another one is Windows. And I have also gone ahead and actually uh, installed web servers on these machines. So on the Linux one, I have Apache web server, uh, which is running on port 80, and that's why I have kept open, if you see here, port 80 for the Linux machine. For the second one, which is our Windows, I have gone ahead and installed IIS, and I have also done tweaking. What I did is I went ahead and changed the port for IIS from port 80 to 8080. Okay, so I changed the port. I'll explain you the reason. So I did that, and you can see that I've opened that port 8080 for this particular Windows machine. Uh, One more point to understand when you are doing this particular tutorial on your own, right? When you are trying to set this up, understand that if your IIS is running on a custom port, you will have to go to your Windows firewall settings and you will have to open that port in the inbound rule. Okay, so if you go to your Windows firewall settings, you will see options of inbound and outbound rules. Go there, add a new inbound rule for the port 8080, and then it's simple. Just give it some custom name, and then request would would successfully come to your instance from from outside as well. So I've done that, and respective websites are running on both the instances. Okay, now we will go ahead and we will understand how to launch network load balancer. So just please see that these 2 instances, Linux and Windows ones, are launched in the private subnets. And I am going to launch my network load balancer into the public subnet. This part is kind of same as we did earlier in the application load balancer or in the classic load balancer. Okay, so I'm going to keep the load balancer in the public subnet, and the targets or instances which would actually serve the traffic, where application is running, that would be there in the private subnet. Okay, so moving forward, let's go to the network load balancer. We'll go ahead and say create load balancer. You can go to EC2. In EC2, if you go to the load balancer, if you go and click on load balancer, you'll come here. You can say create load balancer, and I'm going to create a network load balancer. I'll go ahead and give it a name. So let's give it a name as test 001. I want it internet facing. And here is something. So the reason why I have created two instances and I'm running two different websites on two different ports, right, on those instances, that is to explain you this concept. It's possible that I can go ahead and have multiple listeners here. So why am I creating these listeners? These listeners are going to help me to basically decide and distribute the traffic to different target groups. Okay, so for example, later on, I can achieve this particular feature that if somebody hits my NLB or network load balancer on port 80, I can send that traffic to target group 1. And if somebody hits my NLB on port 8080, I can send it to target group 2, right? I need not set up two different load balancers or anything like that. I can go ahead and basically filter the traffic and distribute it based on the listener. So I have created two listeners, and I'll show you how do we make that relationship as we go forward. Okay. Uh, Please remember once again, the two EC2 instances which are there, one is Linux, one is Windows. On the Linux, a website is running on port 80. On Windows, it is running on port 8080, right? 8080. All right. Next, we need to choose that where do I want to keep my load balancer. So I want to keep it in my VPC. And within that, I'll go ahead and choose that in which subnet do I want to keep it. So in 1B, I'm going to keep it in the public one. In the same way, in 1C, I'm going to keep it in the public one. Now, as you can see, there is something new here. There is an option of elastic IP. If you want, you can go ahead and even give an elastic IP per subnet to your network load balancer. I'll explain you that why is it useful in certain scenarios, though it is not mandatory, but if you want, you can go ahead and give that. All right. So if you want, I have few elastic IPs, I can go ahead and just give it. Okay. If you want to apply any tags, you can go ahead and give that. I'm just leaving it. I hope all of you know that part. Now we need to go ahead and configure routing. So, of course, there are no target groups already. So I'm going to create a new target group. So I'll name it like this. Let's say TG Linux. Okay. And if the traffic is coming on port 80, then it should go to TG Linux. And the target group contains what? Now, if you remember the video which you saw in the application load balancer earlier, in the target groups, only instances can be there. But in case of network load balancer, the good thing is, uh, I'm sorry, even in application load balancer, now you can have instances and IP addresses. In the same way, here in network load balancer, you can have instances and IP address. What's the benefit of that? The benefit is it's up to you that you can send or you can basically distribute the traffic from your load balancer to an instance within your VPC, or you can also serve the traffic from an instance which is there on-prem, right? So think of a scenario where you have a VPN connection or a direct connect between your on-prem data center and your AWS cloud, right? So you have VPN connection between this. So that means, yes, traffic can flow between your VPC and your on-prem, right? Now, when that happens, now with the help of application load balancer and network load balancer, you may do in such a manner that one of your target group has got the targets or the machines which has the application running. It is not there on the AWS cloud, rather it is there on-prem, right? And still it would be able to serve the traffic. So that's a good thing. That was not available with classic load balancer ever. And earlier it was not there with application load balancer as well, but after some time that feature was introduced, right? So that's why an IP is also supported. Now in this case, I don't have an on-prem thing, so I'll just go ahead and show you with the instance. So we'll just say instance. You can set up the health check, of course. Uh, so as part of health check, the default thing is that it will try to do the health check on the port which you have specified above, which is port 80. In case you want to override and specify some custom port, you can do that as well. Other things are quite same: healthy threshold, unhealthy threshold. After how many attempts an instance should be marked unhealthy, and things like that. So those things are given here. What should be the what should be the uh, at what interval the check should happen and things like that. All right, we'll say next. We'll go ahead and actually register target. So register target means the target group which you have created. You need to put certain instances inside that, right? Then only those instances would be able to serve the traffic. So we can go ahead and do it here. For the Linux one, we can add. So this one I will attach to the TJ Linux, and we'll just say next, and we'll say create. So you might be thinking that we have not created anything for Windows. That's true. We will go ahead and do that, guys, and we'll just set it up. So this is created. Now I'm there on a different tab, target group. As you can see, we have first target group created. I'll also go ahead and create one more target group. So we'll say create target group. Let me call it TG Windows. Uh, and in this case, I'm gonna say TCP 8080, right? Because the Windows machine is having the traffic on 8080. Type is going to be instance, and the scope of this target group is my VPC. Please understand, guys, many of the times I get this question from you that uh, I mean, people probably get confused. They think that target group is related to a subnet. Understand it's not. Within a target group, you can have instances which are there in different subnets, right? And hence, which are there in different availability zones. So understand that the scope of target group is there at the VPC level only, right? Within that, you can have multiple instances which belong to different availability zones. That's possible. All right, so protocol is going to be TCP. I'm just keeping the health check at the same 8080, so that's fine. I'll go ahead and say create. So one more target group is created. Let's go and add you know a, basically an instance to it. So I'll go ahead and say Windows, say add to register. Okay, save. Now, as you can see, our target group Windows has got an instance, and target group Linux also has got an instance. So this for demo purpose, so I'm keeping one instance. You can have n number of instances, guys, in the target group, and also it is possible that if you're trying to set up auto scaling group, right, your target group can be related to auto scaling group as well. So what would happen is your auto scaling group will launch more and more instances within your target group. That is also possible. Okay. uh, all right. I have videos on auto scaling group already in place. If you want, you can take a look at it. Okay, now I'll go back to our uh, load balancer. Here, as you can see, we can go to listeners. We can see that there are two listeners which we defined. So I'm going to edit it because the 8081 should go to TG Windows, right? So I'll go and select this, say edit, and I'm gonna, we cannot. Okay, we will edit this and we'll say TG Windows and we'll say tech. That's also, you can add only one rule, right? Understand that the way it works here is that for a particular for a particular listener, right? For a particular listener, it can go to one particular target group, right? What I'm trying to achieve here is now if I go ahead and hit my NLB on port 81st, it will go to a completely different target group. If I go ahead and hit it on 8080, it will go to a completely different target group, right? So let's go ahead and try to do that. I'll go here and try to copy this DNS. Okay. Um, so say enter, and you can see that because this is on port 80, it is opening the Linux one. Now let's go ahead and try to port 8080. When you don't write anything and it is running on HTTP, the default port is 80, of course. That's why it went to the Linux one. Now if we do 8080, it should go to the Windows thing. Let's see. All right. So as you can see on the port 8080, we got the Windows website. I paused the video for a few seconds in between because uh, our target, the Windows machine, that was not healthy. So all of you know, right, that when we attach a particular instance behind a load balancer, the health checks start, right? And those health checks need to pass, certain number of health checks need to pass first, then only your instance becomes or your target becomes healthy. So it was not healthy till that time. So I just paused it for a few seconds, and after that, now it is in shape. So in case you also find that problem, please just go ahead and look at your target groups, look at the targets there. For example, you see here, go to your target group and look at the targets, and you need to see that it should be healthy, right? If it is not healthy, if it says initial or unhealthy or things like that, that means if it says initial, that means of course it is initializing. You need to wait for some time. If it is unhealthy, then you need to look at the whether the application on your instance is running or not, right? That you need to check, or else you will have to see whether the ports are open on the operating system level in the security group of your EC2 instance or not. You need to go ahead and look at those stuff. Okay, so I hope this part you understood, that how to set up network load balancer. It's very easy. It's lot very much similar to how we used to do classic load balancer. The only difference is that now target groups have come into picture, and also we can have this relationship. We can define this relationship which I showed you here, that you can go to your network load balancer and you can define that which listener should be sending the traffic to which particular target group. You can go ahead and define that. So that's the additional thing. Now there are a few more features about which I want to talk to you about, which I will do now. If you would have noticed that when we created this load balancer, we did not choose any security group for this load balancer. There's a reason why they have done it that way. So I'll talk to you about it now. Quickly, you can see there is a delete protection also available. Same like our EC2 termination protection. Same way you have delete protection and cross-zone load balancing, which you can enable here at your load balancer level. All right. So let me minimize this. Now I would like to talk to you about some of the features of load balancer, about NLB specifically. So you already know that what load balancer does. They typically, distribute the traffic among different targets. Now these targets could be EC2 instances, it could be IP addresses now, and even containers are supported. Understand that uh, with ALB and NLB, all these things are supported. In the classic ones, it was only EC2 instances. Okay. Uh, network or basically layer 4 and layer 7 load balancer. So layer 7 is your ALB, layer 4 is your NLB. So here you can, on the layer 7 side, you can serve traffic which is of HTTPS type only, and not the other TCP ports you cannot specify. But in case of network load balancer, you can specify any TCP port. Uh, in case of network load balancer, the traffic which is coming, think of a scenario that the traffic is coming from some user, right? And that user is somewhere, let's say, is somewhere in US, and from there, the traffic is coming to a network load balancer, which is there hosted in Sydney region, for example. So, uh, in case of application load balancer, that particular connection gets terminated at the load balancer in case of application load balancer. And then that request gets forwarded to the instances behind the load balancer. Whereas in case of network load balancer, it just does the work of forwarding without terminating it here. That's why in case of network load balancer, you don't have any SSL offloading possible as well. That's not there. And that is the reason, the second point which is written, this is the reason why there is no security group available at the network load balancer, because at the load balancer level, there is no filtering happening at all. All it does is network load balancer receives the traffic and just sends it to the respective EC2 instances. That's all, right? So all the filtering, if you have to filter the traffic on particular port, or let's say uh, if you want to allow the traffic coming only from certain IP addresses, those things you will have to define in the inbound rule of the security group of your EC2 instances. You cannot do it at the network load balancer level. There is no security group there. Whereas in case of application load balancer, you have a security group available there, and hence you will define the inbound rules appropriately. Mostly, of course, you do anywhere allowed, but then if you want, you can go ahead and restrict that as well. Plus, it is also important to understand that the connection terminates there in case of application load balancer, and then it gets forwarded. And that is related to the next point which is written. The header gets modified. So what happens, we have discussed earlier that in case your application needs to know the IP address of the client or IP address of the sender. So in case of application load balancer or classic load balancer, we discussed that you need to take it out from the X forwarded for header, right? Because the source IP would look like would actually become the IP address of the load balancer, because the new connection is originating from the load balancer to your EC2 instance. This is in case of application load balancer. But in case of network load balancer, as I told you, the connection which is coming, it doesn't get terminated, right? The same connection continues, and hence what would happen is the source IP of the client or of the sender would be preserved, right? So that's a good thing. All right, these are three types. I think all of you know this, right? So classic load balancer is the older one. Here is a quick comparison. This is available on AWS website as well. SSL offloading is possible in application load balancer, not possible in NLB. IPS target is supported. So I told you that via target groups, you can now specify any IP address as well, which would be serving your traffic. And this IP address, which I'm saying, where could this IP address be? It could be maybe within your VPC, right? Or it could be even in your on-prem data center, and it could be connected via VPN or direct connect to your VPC. Okay, path-based routing or host-based routing, that you can do only in application load balancer. If you go ahead and look at our ALB video, you will understand that you can go ahead and define rules. You can say that if my request contains this type of path, for example, if my request contains anything .jpg or anything .aspx, send it to target group 1, right? That type of thing you cannot do. You cannot apply logic on the content of your request, right? You can based on your URL or the content of your URL, you cannot send that traffic, or you cannot distribute the traffic in case of NLB. All you can do is based on the port, as I showed you. So based on the port 80, I was sending it to a different target group. Then based on port 8080, I sent it to another target group. I hope you understand that. If not, please try to look at both the videos once again for a few minutes, and it would help you. A static IP address is only supported in NLB. As I showed you, that you can go ahead and specify static IP addresses for both the subnets. WebSockets are supported in ALB and NLB both. In case your application uses that, you will get benefited from this. It was not there in classic load balancer, and even container support is available. All right, good. I'll just quickly talk about this. I think we discussed this is about these things already. It supports all the different TCP ports. Static IP support is there. Very good for applications which have long running connections. So really good. Things which are similar to ALB in case of NLB. If you go ahead and see my Lambda video, I talked about the APIs as well. The way AWS has done is for the classic load balancer, the API class is ELB, whereas for ALB and NLB, the API class is ELB v2 version 2. So all the functions or the API calls which you would be using while dealing with ALB and NLB are going to be kind of same. right? And all the concepts of listeners, targets, target groups, those things are as it is, right? Between ALB and NLB, just you need to understand that you have more filtering available in case of ALB based on what the path or what the request is. Based on the URL, you can go ahead and filter and distribute the traffic to different target groups. Okay, please do look at the ALB video if you have not seen yet. So this is how it works. So so I created a network load balancer. The traffic comes to this, and then I created two listeners. One was there with port 80, another one was there with port 8080. The 81, all the traffic goes to one target group. For the 8080, it goes to another target group, and then I had some instances running here and another instance running here, and traffic goes back. So we have already seen that what listener is. We define a port and protocol. So we define TCP 80 and TCP 8080 as the port and protocol for the two listeners, right? Okay, at least one listener would be needed, or else your NLB cannot get created or will not work. Target groups, we talked already that you can go ahead and have target groups. You are going to keep this, you are going to associate it to your load balancers. Understand that logically, if you see, target groups are independent entity, right? So it's possible, I mean, it is perfectly possible that when you delete the load balancer, target groups will remain there as such. If you want, you'll have to delete them separately, right? So, but then based on the rules which I showed you here, if you remember, the rules which I showed you here, based on the rule which you define, you can say that from this particular listener, the traffic should go to this particular target group. So based on this rule which you define, it goes or it gets forwarded. Okay. All right. As we discussed that now target groups actually can contain not only EC2 instances but also IP address or containers. So that's possible. We talked about that IP addresses which are either in your VPC or available via direct connect and which are there on-prem. So you can do that. IPS target. So typically you will keep those IP addresses which are your private IP addresses. So there are ranges defined for your private IP addresses. So please go ahead and keep the IP addresses in that way. The NLB is static IP. Yeah, so we said that we'll talk that why is it helpful or why is it useful. So many of the times you would have seen that in the firewalls you only get support to specify IP addresses and not the DNS not the domain names, right? So that's the thing. Now with NLB, it is possible that you can go ahead and specify the two elastic IPs as I had shown you. And the good thing is those elastic IPs would not change. And hence, in any of your firewalls, if you want to specify some rules, you can specify it using these two static elastic IPs, right? And hence, you need not worry about changing those rules at all. You may go ahead and even if you say, even if worst case, like think of a scenario, even if you have to, in case, terminate your NLB, right? You can even stand up a new NLB and specify the same elastic IP, and you don't have to change anything in the firewall rules, right? So that's a good thing. Also, from your NLB, the traffic which is going through, that would always go through these elastic IPs. It's not like other case as it is there in ALB or classic ALB, that the IP addresses or the public IP addresses which are being used, they keep changing, right? That would not happen here. Here, those elastic IPs would remain constant or would remain static, and hence you don't have to go ahead and change any rules in your firewall. That's a really good feature. Okay. Uh, and this is the last one which I already talked to you. The traffic which comes from any of the client which is coming to your load balancer. So because the connection is not terminated at the load balancer level, the client IP is preserved and that is sent further to your target. Okay. In case your targets are not EC2 instances and you are doing it via IP address, what you can do, you can go to your target group and enable proxy protocol version 2, and in that case you can once again use the same X forwarded for thing and basically take the client IP address from the header. I will show you where you can do that. So if you go to your target groups, in the target groups, just for a moment consider that, let's say for this target group, the target type would have been IP address. So what you can do is you can go here, say edit attributes, and you can enable proxy protocol v2. When you do that, what happens is same like how it was doing in classic ELB, right? What it would do is it would actually put the client IP address in the X forwarded for header, and then your application can take the IP address out. So that's the thing. Just to summarize at the last, guys, if you are looking at TCP, meaning custom TCP ports, if your application is running on that, then go ahead for network load balancer. If you are typically using, HTTPS, then of course your application load balancer would be the right thing. I hope you understood that what NLB is. There are different things which we talked about. Certain concepts which are same as classic ELB and application load balancer. I've not repeated that to save your time. There are videos available. You can go ahead and look at it. There's a lot of time and effort which goes here, in making this. So if you got benefited, I request you to share it with your friends and like this video. Subscribe to our channel and get more videos which are coming up. Thank you, guys. You are watching this video on Knowledge India. We request you to subscribe to our channel and press this bell icon so that you can get updates regarding all our upcoming videos. You can also go ahead and look at our playlists. There you can find different videos related to certifications. If you have any query or request, go ahead and post it at the community tab. Thanks for watching. See you.